to tell us about the strange case of the double screen of disk.
Okay, thank you so much. My name is Espejo. I come from Colombia, where I work as a cloud architect for IFX Networks, a major ISP that runs a public vCloud service for customers all over Latin America. I want to give thanks to the vBrownbag community, especially to Jonathan Frappier and John Harris, for the opportunity of being here. It's a great honor for me. Today, I plan to discuss with you a topic that I have called the strange case of the PSOD. Hope you like it. So let me start with the problems definition. And let me use this to change. Okay, there it is. Maybe the majority of the audience here have seen a screen like this before. This is the so-called purple screen of death, which is a condition, or which is a colloquial name for a condition when the VM kernel is unable to handle an exception or to recover from previous error. This is not the official definition, and we don't know of any official definition, so we built this one from our experience and knowledge. The real problem with the PSOD is that it results in downtime for customers, even in the presence of an HA cluster. So a fair knowledge of the condition can help virtualization architects and administrators to develop methods for mitigating the risk of a PSOD. So the first row of the PSOD screen is pretty obvious. It is the release version running at the host. The second row shows the exception number as defined by the CPU manufacturer. We have found that the most common ones are the GP exception 13 and PF exception 14. The GP, or General Protection Exception, is raised by the CPU when it finds an unrecoverable error while trying to write a result to the memory. The PF exception 14 is raised by the CPU when it finds that a bit reservation is violated or when a memory operand is outside limit. As a general rule, a general protection exception will be triggered if a page fault occurs more than a time. After that, the PSOD section shows the actual location of the error expressed in CPU registers. Below that, it's this physical CPU number that was running the instruction that caused the PSOD. At this point, it's recommended that you can retrieve support logs right away after the server is up again, so you can file a support request, and also to keep track of the CPU number, because if the problem repeats over the time and the CPU number remains the same in every occasion, it's likely that there is a hardware problem with the CPU and it will have to be replaced. After that is the stack trace, which is the actual operation that the VM kernel was running when it triggered the PSOD. Most common operations here are VM kernel modules trying to access PCI devices or trying to release an interrupt on that kind of device using the BIOS as middleman. At this point, it's a best practice to configure a diagnostic partition previously with at least 100 megabit of disk space so the host can card dump safely. And also, if you want further information about this topic, we recommend the VMware KVs shown on the screen, and also the CPU manufacturer programmer's guide that both Intel and AMD publish. These are very deep technical documents, but it's a good idea to know how the CPU works. Moreover, when server virtualization relies on the efficient allocation of CPU capacity, among other resources. So the real history about or behind this particular PSOD that you can see on the screen, it happened to one of our servers in one of our data centers. I won't name the vendor, but it's the word with H. And after we followed all vendor recommendations regarding firmware and driver updates, the server began to experience PSODs every 2 to 4 hours. And for 1 week, we had no clue about what was happening inside the host. You know, we opened a support case with VMware and with HP, and we were in the middle of both vendors blaming each other, and we had no clue about what was happening. At the end, it turned out that VMware was right, but we had to find by ourselves what was the root cause of the problem. And it was a patch for the BIOS that HP didn't include on the service pack for ProLine server. So today we would like to share with you a common set of practices that have proven to be efficient in our environment in order to mitigate the risk of a PSOD. As you will see, these are not very deep technical instructions, and some of them can seem pretty obvious, but sometimes the best way to solve a problem comes from the prevention and with a bit of common sense. First, keep hardware drivers updated. And this advice really comes tied to a second one, which is avoid driver firmware version mismatches. As I told you, it's a pretty common mistake, or it's a pretty common problem, even if you follow all vendor recommendations. While deploying third-party services, consult for technical support from the third-party provider, because it's surprising to see how many times the third-party product documentation doesn't tell anything about real problems with the ESXi version running in your environment. So it's better to ask for support before the deployment of that product in order to reduce a source of error. This one is pretty common and pretty obvious. Only use hardware listed on the HTL, but it's important not to forget about it. And finally, considering using host profiles and even host auto-deploy, because the more you can standardize host configuration, and the more you can automate and orchestrate the whole deployment process, the less sources of downtimes or problems you will have in the virtualized data center. Thanks so much.